Well, we should start with John. John has big news.
Yeah, getting used to this whole thing and
Yeah.
little 3-hour stints of sleep here and there. I'm still alive, so yeah, it's all good. She's actually really well behaved, not too much crying and cute as hell. So
Excellent.
Get her, baby.
yeah,
Again.
But yeah, other than that, yeah, I don't have really too much new. I'm trying to pick away at that tiling stuff there, Dom. I see you finally picked up some stuff there, and yeah, I was just getting into it. So maybe I'll bug you here as I slowly get back into things.
Fair enough. And everyone's happy and healthy?
Oh yeah.
Yes.
Well, once we got back from the hospital, the whole COVID thing, it's really weird. Like, it's just like the baby was born and it was just like us, like no parents, nobody could come, and it was just like what do I do?
Yeah.
So yeah, and then we had to stay there for a couple days, and it was just it was tough just being alone without much help. So, but we're all good.
Excellent. Well, very glad to hear it. Congratulations.
Thank you, guys.
Excellent. Cool. Well, I see Dom in the middle of my screen. Would you like to go next?
That Skip Chantal is behind me, and I'll talk later.
Sounds good. Joe.
Sure. We've I put out that pull request after the meeting last time. People have been looking through it. I've been trying to implement a few little things in there. There is I think it's basically ready to go. I think we've kind of come to a consensus on most things, except I still can't think of a good word or a good name for that mesh tensor function. I've been trying to wrap my head around it, and I don't. So if anyone, the function does is it's the function that takes that kind of fancy input for the cell width vectors, like that, and then it changes like that expansion factor out to it takes that tuple of numbers that describe like the padding cells, and it expands that out to like the actual widths. Like it does that operation for us. So that's the function that does that, and kind of takes all of those things and handles all of that at the same time. And right now it's called mesh tensor for some reason, and I feel like that's just because it is the function we use to make tensor meshes. So it's kind of like a self-referencing name almost.
And create tensor?
But it's not like creating a tensor, it's creating
a
one-dimensional array of cell widths from our tuple.
Get 1D cell width.
Maybe expand cell width, expand.
Could it be like something to widths?
Probably.
Like an operator, you're taking it from whatever you're defining your initial input is to
cell
widths.
Yeah.
Yeah, cell widths.
Or you could go the other way, widths from.
Ooh.
This? I don't know.
Like I like describing it in the name that it has something to do with cell widths because that's what we're getting out of it.
Yeah.
I can't figure out what to call what we're putting in because it's like let's double check here. Its primary use is that it takes that tuple of number and expands it with these expansion factor.
Cell widths from tuples. Cell widths util. We could just make it vague.
It's like I don't like that mesh tensor name because that is like not descriptive at all.
Yeah.
Maybe create cell widths.
Or like unpack cell widths.
I kind of like that actually. Unpack.
Yeah.
I like that actually.
And you could go the other way and it could be condense or something.
Yeah. I like that kind of, I think that's a good one. I like that.
Yeah, I'm helping.
Yeah. Because took a little bit just to talk through and think out. I was going through and also implementing or trying to make sure that we weren't internally causing any matplotlib deprecations. My thought there is that, I think I put it up on the PR as well, but I specifically want the deprecation warning to be thrown if a user supplies a norm to the p-color or to the plot image, plot grid commands, if they supply a norm and a clim or vmin, vmax, because that is what matplotlib is trying to dissuade, right? We don't, if the user does that on our end, we don't want to fix it for them, because if we do that, then that is what matplotlib is trying to avoid.
Right.
They don't want people to do that, right? They want people to fix it on the way that they're calling the functions.
But then,
because if we try to take those inputs and, you know, fix it ourselves, then we're committing the same error that matplotlib is trying to avoid.
but is it logical for a user that uses a discretized plotting function that he can provide a clim if he doesn't use a norm, but he can't if he uses a norm? Then I would get rid of the clim and just use the matplotlib functionality vmin and vmax as matplotlib uses. Because like this with clim, we kind of provide some functionality, but only for some cases, and that doesn't make sense.
Clim is the same as providing a vmin and vmax. It does the same thing.
No, in general, in matplotlib, no. I think it's actually
It did. In the way that our plot image, plot grid, plot slice commands were
right.
working,
In our function.
we took the clim input and put it into vmin, vmax of a p-color mesh. We did that every time.
Right.
So that way, so what would happen is no matter what, if the user supplied a norm argument to the plot slice and plot image commands, we would recognize that, our code would recognize that that clim was none, and it would create vmin and vmax from the function or from the values, and then put that into the color bar, or put it into pass that to the function. So if the user supplied a norm, so we were always supplying vmin and vmax to p-color mesh, no matter what. Does that make sense?
Yeah.
No matter what, if we were either taking the user's input or defining it for ourselves, or defining it within the functions.
Yep.
So that, therefore, if the user supplied a norm to p-color options, we would take the norm and still pass vmin, vmax, or still create a vmin, vmax and use that, which is what was causing deprecation warnings. So we don't want to do that internally. And what matplotlib deprecation is doing is it's discouraging users from providing a vmin, vmax, or equivalently clim in our functions that we've been using, and a norm at the same time. They want to encourage users to create a norm and only supply it if they want to use vmin, vmax. They want users, or if they want users to supply a norm with vmin and vmax, they want it to be set on the norm.
Should we just get rid of like the default behavior that we always grab that? And
that's what I did. So I changed it to where I got rid of that default behavior. And basically what happens is that if clim is provided, then it will put those into vmin, vmax of p-color ops. That's the only time it'll do that. So that way we mimic the deprecation behavior of what matplotlib is doing. So if going forward, if someone would provide a clim and a norm, it would throw a deprecation warning, as it should.
But yeah.
Does that make sense?
Like I was just curious, why matplotlib sort of deprecating that function? Like what's
it's kind of ambiguous. So let's say what would happen is if the norm had its own vmin and vmax, and you then supplied it vmin, vmax, it's undefined behavior which one it would actually use.
Oh, okay. So it's not necessarily using the Vmin and Vmax that you're putting in. So
I don't think it's defined, and it's unclear which, and they can't really document like, oh, if the norm has Vmin, Vmax, it's going to use those over the V and Vmax that provides the function, or the other way around. It's hard to, that kind of behavior is undefined, and that's what they're trying to avoid.
okay.
So that was my purpose for doing it the way that I did.
So, and have a little bit more practical sort of question then. Okay, so if I want to use a log scale,
Yep.
I want to put a Vmin and Vmax, I want to make sure that is correct. You know, do we have a way to make sure? So it seems like Matplotlib doesn't.
No, you have to put it into the norm. If you have log norm, you put in Vmin, Vmax into the norm. That's the Matplotlib way.
Okay.
Yeah.
So you supply it when you're creating the norm. And I think you have to do that on a log scale.
Right.
Or,
no, it's not.
You
You don't have to.
But if you do want limits on a log scale, it should be provided when you create the norm. You can create the norm without them, in which case it'll just automatically choose them. But if you do want to give it limits, you need to provide it on the norm.
Well, I think that the confusion comes because often the norm is just passed into the dict of p color ops, so you create it, but just by providing it to the dict, so you're not thinking about it. You think of it as another p color opt keyword rather than creating a norm.
Okay. So the proper way is basically just putting like Vmin and Vmax through that log norm.
Yeah. Okay. Yeah, because if you update to Matplotlib 3.3, it will throw you warnings all over your Python if you don't.
So that's why I said we don't want to do it internally. If the user does it, it should be on them to fix it, but we're not going to do it internally.
Yeah, no, I think my concern was just, why do we have even a clim? So we transform a clim to Vmin, Vmax, but not if there is a norm. So I would have said we can get rid of it, but yeah.
I kind of want to keep it around because it's a nice quick way to add Vmin and Vmax instead of creating a dictionary and putting it into that. It's just kind of a shorthand way of doing it.
Okay, but then it could be called Vmin, Vmax. Yeah. But yeah.
So my default behavior was just to leave it the way it was. Like leave the inputs the way they were. Like unless we have like a really specific mean or specific purpose to change the way that those functions are called, then I would just leave it the way it is.
That sounds good. Joe, are there any other things that would be helpful to sort of walk everyone through with this pull request? Because it is a pretty big renaming.
There's a lot of changes to look through. Yeah. I tried to document, or I think I put in all of the renaming.
Yeah.
Specifically into the comments of there. Like I said before, I left the tests as untouched as I possibly could. Just so that way we ensured that the deprecations were being handled correctly. And that it wouldn't really break old code right away, or it should be just fine. Unless the only thing that might change is that, the only thing that might change is that if people were importing utility functions from the modules that they were defined in, as opposed to importing them directly from discretize.utils, that will kind of break. But if they were importing it directly from discretize.utils, it'll still work just fine, which is what everything was imported as in SimPEG. It was imported that way, so it shouldn't break anything in SimPEG. And the other thing is, like I said, those like vector n thing properties, the shape properties, as they're now going to be tuples instead of numpy arrays. So you won't be able to just the point is that, okay, those are actually like quantities that if somebody got back, they shouldn't be able to change it. Right? If somebody asked for the shape of the mesh before, you could reassign a new number to that array, which kind of is like undefined behavior. So we're going to keep them as tuples, so that way they're immutable. You can't change them. But a side effect of that is that
Not that easily.
it's
Yeah.
The side effect is that, okay, you can't do things that you would expect to do with a NumPy array. Like you can't add 1 to all of the numbers just by doing that plus 1. So
Excellent.
I think those are the biggest things about it.
Thanks, Joe. That's exciting. That's going to be a nice big cleanup that should help make it a lot more usable and hopefully transparent for users. So that's a huge job.
The other purpose is making it, like, if you look at the way the source code is organized now, I think it's a little bit more clear. Like, okay, we're putting the emphasis on the meshes here. Those are the base things in the package, right? So those are the things that are easily open up and okay, if you're looking at the source code, okay, I see that there's these X number of mesh types. Then there's other things on top of that. So we've hidden like the Python extensions kind of are a little bit better, so it doesn't get all populated into the main branch or the main folders. Yeah, but that's about it for now.
Excellent. I guess what else do you want or need from folks here for that pull request?
I mean, I guess if people wanted to take it in and start using it and make sure it didn't break any of their stuff too crazily, that would be good. So people could just, install it, like use it locally for a little bit and see if it is unmanageable.
Could you do like alpha or beta for a week or two? That might
probably could, yeah.
That might be cool. Like once you know that it shouldn't change much more any longer.
Excellent.
Cool.
Thanks.
That's really cool.
Dieter, would you like to go next?
Yes. Yes. We did, I think in this joint paper we do, we had the help of Bain to get the tetrahedra meshes out to matplotlib. So we have now quite exciting results that compare the tensor mesh, octree mesh, and tetrahedra mesh CSCM results and the corresponding fields, which is kind of nice. I don't think I've ever seen a comparison like this. It's not that easy to actually plot a tetrahedra mesh in matplotlib. So Bain promised he will play around a bit further to improve that image. It's full of lines, which is not really nice to see yet. And other than that, I had this chat with Joe, and Sogi helped me to get my head around SimPEG internals. And I created a branch, if anyone is interested, where you can use EMG3D as a backend for SimPEG computations, given you do EM, not DC, but EM at a certain frequency. So yeah, that is something. It's just a draft out there. It will probably stay in this status for quite a while. But it's just a forward modeling, but in principle, it shows that the interaction works, which is nice.
That's really exciting.
Dieter, I haven't had a chance to look at that yet, but were you able to use the field object?
What do you mean? I put it just in F as it's normally, yeah.
Okay, so
it's stored then as a field object, and you get the receiver out of it if it's electric or magnetic, just the same way.
Right. So have you tried let's say you're solving E. So in our field object, it supports to compute B or H, J. Have you sort of tried that kind of functionality?
No, but I would just assume that works. Why wouldn't it? It stores the same field.
It needs a few operations to go between them.
Yes, yeah, but they don't change these operations, right?
In theory, but you're using a slightly different sort of discretization and formulation. So
no, but then I compared if I use Pardiso or EMG3D, and compare the two results, and they are in the order of 1 to the power of minus 12%. So they are literally the same. The E
Yeah.
fields, and that's the only thing you have, even if you use Paradiso, right? After you calling a field.
What I meant is slightly different in a sense. So that field object gives you a numerical operator that can evaluate, let's say, B from E or J from.
Yes.
And that kind of assumes some sort of formulation that we're specifically using. So I wasn't exactly sure how, I mean, in theory that might work well, but I wasn't sure that you are getting sort of expected result. I was just curious.
No, but I compared receivers, right? So it gets these receivers from the field object. It doesn't get it from my result. It gets it from the field object, and they are identical. So then,
okay, right. Good, great
I
point.
would assume that anything it derives from that would also be identical, because the fields themselves, well, yeah, I have these receivers, I get them from it, and they are the same. So I assume that any derivative of it is the same too.
Oh,
I might be wrong, but.
Right.
Yeah,
But I thought like,
go ahead, Saki.
I thought like you're using different interpolation, let's say spline interpolation, which is more
No, but I
sophisticated.
don't do anything of this. That I leave in EMG3D for, in what I included, I only compute the field at each edge and give that back to SimPEG. That's the only thing I do.
Great.
And put that in the field object, and everything else is handled by SimPEG. So that's why I assume it's the same. But that's why I think you should play around, and then you will tell me if it screws it up or not.
But have you compared, like, okay, so you do like a SimPEG object to evaluate at receiver location, but you can do the same operation by using everything in the EMG3D, right? Have you
this comparison we did already before between SimPEG and EMG3D, yeah. So I just took those comparison examples, but now run them twice with SimPEG, once with Paradiso and once with EMG3D.
Right. Okay.
Maybe. I guess, yeah.
So
have a crack at it and tell me.
Dieter, what were you using to do the tetrahedral simulation?
In the comparison, there's Custom and PetGem, and they use, well, Custom uses Phoenix, and PetGem uses PetSC, I think.
Okay.
Is that right, Lindsay? I think so, right? One uses Phoenix and the other one uses PetSC.
Yeah, I think so.
Yeah.
So something that we brought up earlier, but where I was thinking of adding like tetrahedral mesh functionality to discretize, so we could use that as well in there. So it's just something that I was curious what you were using to do this simulation actually. Because obviously it's not supported in SimPEG right now.
And I think as a solver, at least PetGem, they use mumps and the other one as well.
Yeah, I'm not really concerned about the solver. It's more so like, how did you set up the system? So
TEDGen and Phoenix, or TEDGen and PetSC. No, Mesh.io. I think Custom uses Mesh.io and then PetSC, and the other one TEDGen and then Phoenix. Or yeah. I can't tell for sure.
So did you so like setting up the actual PDE that you're solving? So you don't know how that was done?
I can send you the links to the two packages.
I think GeoSci.xyz provides those operators as well as Phoenix. So Phoenix is
right. Yeah, I know. I've used Phoenix and that kind of thing before. So I was just curious if like somebody else had already used those created like, oh, this is doing EM simulation using Phoenix, or this is EM simulation using the PetSC, like, you know what I mean? Like,
the first bottleneck that I had was installation. That was like headache just to install Phoenix on my machine, and that's where I stopped.
It's a really nice library and stuff. I really like it. It's for finite element stuff. It's a lot of fun.
PetSC seems to be pretty straightforward now to install. It's not that hard. Yeah, I put it on the last machine a couple months ago and went relatively smooth. heads up.
Yeah, I think I was using PetC for Pi. So I guess that C library may be very straightforward to install, like the Python wrapper was not.
But I'm not sure. Custom, everything that they use with Phoenix is on Conda, but PetGem with PetSC, it's still a bit more involved to install it, because I think in their install instructions you have to compile some stuff yourself. But yeah, I guess everything will get easier down the road. We just have to wait.
Somebody else will fix the problems. Cool. Thanks, Dieter. Any other? Is that?
No, other than that, yeah, a bit teaching and this, yeah, not much.
Kevin, would you like to go next?
Yeah, sure. So I'm just kind of finalizing the 1D stuff. Yeah, I added dispersive magnetic susceptibility so we can simulate the VRM response. Got all the bugs that I was trying to fix fixed, and all the tests passed, and I've added new tests for all the things I've added. So I'm getting close to a point where I think I may want to bring it into SimPEG, because there's some stuff, I think, basic utilities and analytic functions that probably already exist in SimPEG. So I don't exactly want to perfect it here and then bring it in, because I'm going to have to kind of remove any duplicate functions and some other stuff anyway. So I think once I get through kind of finalizing the doc strings and making sure that the formatting and variable names and properties are all done in the same fashion as SimPEG, I'd like to bring it in. The only kind of remaining item for this is the multiprocessing part. That seems to be broken, so I'm trying to fix that. So it would be nice, especially for the time domain, because it'll be faster to forward model each sounding and compute sensitivities using multiprocessing. So I just need to kind of figure that out.
One other, well, so I think right now though, SimPEG EM1D relies on SimPEG, right? So you should be able to just import any utilities that might be duplicated, right?
That's true.
Yeah, so I don't think that needs to be a prerequisite for getting it into SimPEG. You should be able to import it directly, and that'll actually make it easier down the road too. Does that make sense?
Sort of. I mean, I mostly meant that there's like some analytic solutions that are duplicates of analytic solutions there. So, but it's like tiny details. It's not something that fundamentally changes how the code runs.
Yeah, fair enough. But even with that, if the analytic is already in SimPEG or in GeoAnna, you can just import it rather than have the code be duplicated.
That's true.
It's already a dependency, so you're not introducing any new dependencies by doing that.
Yeah, fair enough. Yeah, I guess so that you preferred that getting cleaned up before bringing it in.
Yeah, that would be great, I think, is remove as much sort of duplication and yeah, because then it's already much more in line with SimPEG before thinking about merging it in, because it's going to take some thought. I don't know, Joe, what your take is, because SimPEG EM1D has Fortran code in it. It's more complicated to distribute. Joe, I don't know what your sort of take is on that.
Well, it's not required. It's written, all that stuff is written in Python as well. So if you haven't compiled the Fortran 90 stuff, it will do those computations in Python. So it's not actually required to run.
Right, but I mean, if we are going to be distributing it, we want to have the default be the Fortran version, because it will be faster.
Mm-hmm. I mean, I still need to go look through that code. Just usually, I mean, it's easier to distribute C code than it is Fortran code. There's no, I mean, the good Fortran, or most of the Fortran compilers on Windows are either hard to get or they don't work natively with the Windows kernel or something. Like, it's just weird. They're just kind of weird on Windows. I mean, there's definitely ways around it. SciPy has, I mean, I know SciPy uses Fortran, and they've done a lot of work to make it easier to use it on Windows.
Yeah, and I think that Fortran 90 file is going to need to be updated because we've added frequency dependent susceptibility. So if you're doing the reflection coefficient for the TE mode, it's not set up to do that right now. So that needs to be updated.
It might be something where you can look through it and like just translate it quickly into C, and get the same sort of speed with it, put the same sort of assumptions into the C code to make it perform like Fortran code. I can look at it. I need to look at that. Check it out.
Sure.
Yeah, I guess I like bringing it into a branch of SimPEG earlier rather than later, because if you kind of try to perfect it too much when it's living in its own little space, you might have to undo stuff. It's kind of at a point where it could be brought in anyway. I mean, people have preferences, but it feels like 6 of one, half dozen the other.
Well, maybe the thing to do at this point is, like, it sounds like, so first there's a bit of a step to actually do a bit of like a pull request review and get the work that you've been doing onto EM1D master, right? So that kind of is a first step. And then from there, maybe we just come up with a little bit of a roadmap for what things we want in place before we bring it into SimPEG. Because I think this question about code, are we distributing Fortran in SimPEG? That is actually, I think that's an important question to address. And so just coming up with a bit of a game plan, maybe once the pull request is in, and evaluating from there. Does that sound all right?
Yeah, I think that's a good idea. Definitely before we bring it in, it should be reviewed. And then, yeah, there's still a few details that I need to finish off before I'd say it's ready. So I'll complete that stuff. I want to fix the multi-processing stuff, and then once it's done, make a pull request, get it reviewed, and when everyone's happy, we can take the next step.
Excellent. That sounds good.
All right. Yeah, that's basically it.
That sounds good. Thanks, Devin. Joe, I don't know if you wanted to touch a little bit on sort of documentation, because this, I think, is related to some of the things that Devin might be working on next, or we can table that and chat about that later. What would you, or maybe a quick overview?
I guess the overview is that we'd like to move to it's like a sort of NumPy style documentation of functions. It just makes it makes it easier to read the text strings of the functions and easier to write them. As part of that, I'd like to have more small examples of each of the functions and methods being used. So things like, what does this little utility function actually do? What does this function actually do? Because a lot of the utility functions are just not documented at all. They're just kind of there. So I think that'd be a good place to start as far as that. Especially, it's probably easier to start on discretize because it's easier to move. Then discretize is already set up to handle NumPy documentation style right now. So it'd probably be easier to start there. There's also less utility functions and just kind of have an idea of, okay, this is what we want it to look like when we're going forward. Part of that, eventually, we start with that, then we can move on to documenting classes in the NumPy style, which will take a little bit more thought because as of right now, properties, the way that properties interacts with NumPy style documentation is not nice. The properties package. And we're not really using it to do too much in discretize because all we're asking it to do is basically verify the inputs to a couple things, and then we're using it to serialize some of the base meshes, or some of the mesh, or serialize the meshes. And I don't think it would be too hard to just kind of have that, like implement something simple that does that ourselves within it. It would just, I mean, you just have to like, oh, I need to serialize these two properties and then I can reconstruct the mesh. So you just need a way to tell it, like, oh, look at these two things. So that's kind of looking, and then I'm more concerned about getting like the API. These are mostly changes on the API documentation side of it. So things like, okay, if you look at how NumPy does it, they don't really write too many of the dedicated API documentation files in like the documentation folder. It's rated at, it's wrote into the source code itself. It's written in module.
In the doc string, yeah.
It's in like even in the doc string of like the modules themselves. So if you look at a module and you go to the module, like the init.py module or function inside these modules, you'll see the entire documentation written off there, which is kind of a nice way, like, oh, I import this module and I can see all the thing that it does, like, you know, right away. So that's, and then it's just kind of like listed, like, okay, we want this, 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 this. So that was kind of the way that I see this all going forward as far as the API documentation, documenting each of the individual modules themselves.
Yeah, I think that works really well. And the only thing I wanted to make sure is that there was some separation of, I guess, theory. So obviously it'd be nice if we're solving like the, I don't know, the electric field formulation of Maxwell's equations. It would be nice to just say, this is what you're solving. This is the system you're solving. Yeah. But I do want to avoid really lengthy mathematical derivations and stuff. There should be another place for it. It's really important, but there should be another place for it.
I agree. Like, it doesn't have to live in the API documentation. Just put it somewhere else and put a link to it.
Yeah. Yeah. I guess now that you're bringing this stuff up, I've done some stuff about kind of, improving the organization of the website and thinking about the organization of auto-generating the API. And I guess one thing I thought that would be beneficial for the end user is that if you call a particular survey method like frequency domain electromagnetics, you should be able to import all of the relevant stuff from there. And so right now, things like gravity and magnetics, the analytic.py exists there, and it's all kind of packaged in one spot. But if you go to electromagnetics, there's just a separate directory that houses all the different analytics, but they're still partitioned by survey methods. So it would be nice to come up with something consistent for that, and then consistent names for the types of utilities and where they live. Right now, it's a little bit disorganized.
Yeah. Yeah.
I'm kind of a fan of importing them like into the module. So like at that init.py, as long as they're kind of pulled into there. I don't really quite have a preference on where like the actual definition is inside the Python files and how that's, or like if there's at least, if I would say like, okay, if there's one, if you can define all of like, let's say those analytics, if you can define all of the analytics you need inside a single file, then it'd probably be fine to leave it as a single file like that. But you'd still want to import those functions into like that module level, let's say.
Yeah.
Like into the module. Yeah. As far as like, okay, well, if you have to take it over multiple files, then that would be when it would go in a folder. Like if it makes sense to split the analytics into multiple files, then it makes sense to go into like an analytics folder instead of just one file.
One thought there too is I think, and we can maybe sort of build off of Devin's notes here, but I think a lot of the analytics, it would be nice if we actually had those sitting in GeoAna, is because they don't actually depend on discretize and are sort of, a lot of them are useful on their own. And you might want to use that without having installed SimPEG at all. And so if we can sort of maybe take a look at all the analytics that we have and see what fits over in GeoAna, that I think overall would be a good direction for where analytics might wanna live.
I could see that as well.
This is GeoAnalyst or just GeoAna?
GeoAna. It's in the SimPEG organization. It's not one that we've pushed on much recently, but it is
Okay, yeah.
some of our source definitions and things like that are. So at least a lot of the very simple things like dipoles should all
Yeah.
be sitting in GeoAna. Some of the more complex analytics that we have, like I threw a bunch of stuff in there for the casing stuff, like that should probably get moved over, but those are still sitting in SimPEG.
So then, I guess, could you give me a one-sentence definition of the purpose of GeoAna? Is it just a housing for geophysical analytic solutions?
Yeah.
Okay, then it makes perfect sense to put all that in there. Yeah. Then the other thing I was kind of curious about was we have this thing called I/O, and we use that for DC. Does anyone have a 1 or 2 sentence rigorous definition of what I/O is?
Input, output. I don't know that. I mean, that's complicated. This is like that function in the DCI. It's not an I/O, I guess. It's more like a, yeah, so in some sense it gives you an input of the inversion, but I don't know what it is actually. It's just a like helper to
Yeah. So as of right now, what it is and what it can do
parameters and
isn't
visualize.
really well established. We don't have to get to it right now, but it seems like we want something that imports and exports things and at a high level interacts with the SimPEG code, would let us do like a workflow almost.
Yeah, so I think that we need some, I kind of like that having that kind of class that you can in the basically outside of the problem or simulation class, and that can readily generate input parameters and I don't know, visualize simple data or inversion models or whatever. But yeah, we need something different name, I guess. I/O is not a right wording.
Yeah. I feel like we can leave it until later. We have enough of a list of stuff. But I was just wondering if there was something I was missing, but it sounds like I'm in the same boat as you guys.
Yeah. I think a lot of that is part of the bigger conversation and probably a next phase of development in a sense of like, what are the high level APIs that sit on top of SimPEG?
Yeah.
In potential fields, we have some of the concept of drivers, which I
Yeah.
think is, you know, it's in a similar vein as to what the I/O currently is. And so, yeah, it's another big conversation, but absolutely an important one because that is actually what drives usability for a much broader audience.
Okay, so then I guess in the meantime then, I guess I should be part of the GeoAna group and I should be able to go and I'm not sure. If I'm not, I need to get added to that and then I could contribute towards moving the analytics solutions into GeoAna so that we can call them instead of redefining them.
Yeah, if it works, maybe, I don't know, Joe and Devin, if you both have time tomorrow, we can sort of maybe go through, because we've brought up like a whole bunch of different things. Some of them are related, some of them are not, and go through and maybe prioritize a few items. Would that work either tomorrow or Friday? We can figure out a time on Slack, but that seems like maybe a productive step.
Yeah, I need to work around our normal meeting with Doug and Roman, but that's fine. Tomorrow's good. Sooner the better.
Yeah, free.
Excellent. That sounds good. Okay, well, we'll coordinate afterwards on a time. Excellent. Cool. Sagi, would you like to go next?
I have nothing to really update. Although I actually interact with Dieter a little bit about how to implementing JVAC. So Dieter has a JTVAC in his adjoint problem. But I think I got pretty good idea of actually getting JVAC from pieces of his code. So yeah, actually implementing both JTVAC and JVAC into SimPEG, running an inversion with actually using EMG3D as a backend and sort of SimPEG as a wrapper would be really cool. It will be a cool application. Anyway, Other than that, I was actually in an interesting conversation in these days actually recommending how to use airborne geophysics in Central Valley of California. So this Californian government actually now launching much larger project, basically flying entire Central Valley. So it's about $12 million project. So, and they are actually taking the recommendation from this project and putting that into their sort of RFP. So yeah, it's an interesting situation now where like each partner have different sort of politics and they want to say different things. So yeah, I mean, the process and then pushing conversion is not a turnkey operation, but we'll see.
Excellent. One thought just to put on the radar with the EMG 3D connection, this could be, I think this would be a really cool paper at some point. I don't know where it would go, but like sort of that level of interoperability between different code bases, I think is not super common, especially like because they did, start from different streams, or I don't know, it could be kind of a cool one to put on the radar.
Yes, you should definitely think of that. And I just recall, because Sogi asked about the fields, and I took actually your notebook, Lindsay, from the block model. And the only thing I changed was solver equals Paradiso to solvers equal emg3d.solver. That was the only thing I changed, and it all resulted in the same. So that's why I think, Sogi, that it should be the same, because yeah, I don't do anything else with EMG3D. I don't interpolate at receivers. I don't, yeah.
That's great.
The change was from 11 hours on Google Cloud to 2.5 minutes on my laptop. So it's quite substantial in the computation time. So fingers crossed it works, and fingers crossed your JTVEC idea works as well, and then we're all set.
That's exciting.
Like if you want to, as you're doing it, just test kind of like each operation. So make sure that, do you know how to do the adjoint tests?
Yep.
Yeah, I mean, just test that like your adjoint is, if you need to, okay, if I'm doing the operation, I think this operation is the adjoint of that one. Just double check. And then if you're double checking things as you're going.
I did that in EMG3D itself. So I guess you have to do it when we do it with the, yeah.
Definitely makes it a lot easier to troubleshoot if like, oh, this whole function is not working. Why is the entire thing not working?
Excellent. Thibaut.
Oh yeah. Basically, I'm almost done with the thesis correction, so I'm just going through one last time and get that out of the way by like end of the week or early next week. So
excellent.
To be like done.
Excellent. Cool. Dom, are you able to chat? Are you?
Yeah, not much to say either. We had the whole conversation, right, with the subsurface members, and that made me thinking a little bit of how could we integrate it a little bit closer to with our, let's, for instance, like data / survey objects. If we could serialize them as a subsurface object, that would be, I think, pretty efficient way to do it. And other than that, yeah, it's just the tiling that is still on my list, and it's just a pretty busy week, so I'm gonna get back to it only, I guess, mid next week. Then I'll be a little bit freer. That's about it.
Excellent. Thanks, Tom. Yeah, also, go ahead, Sagi.
Are there any problems serializing the data and survey object currently? I thought that's working.
Yeah, but it's just it would be nice if they were packaged in something that is standardized with other packages, right?
Oh, I see.
Because we want to turn everything into either an X-ray pandas data frame with probably some dictionary that has all the metadata that we want to keep around. So if we can do this, then we can pass it along to other packages.
So that's
like Gimli or GenPy or Fatiando.
Yeah.
Yeah, that's the idea.
Name it. Yeah.
so you were like not just mentioning the pickling it.
And also because what Joe mentioned about the discretized serialization, ideally is it could then also serialize to a subsurface element or object or whatever they call it then. Yeah.
On discretized idea, like it's pretty simple just to return a dictionary and then define a to JSON message on a base clash. It'd be pretty simple from there.
Dieter, on that, was there any follow-up as to when there might be a next meeting, or is that still a little ways out?
Yes. Well, with Bain and Miguel, we might post it rather sooner than later for the people who are a bit interested in the details of the format, and then in the bigger round probably early December, we said, before the end of the year, something like this. But yeah, it will be in the channel over at Swang, in the channel subsurface for anyone who's interested.
Okay. Yeah, if you could ping a few of us, I try and keep an eye on that, but if my name is mentioned, I will definitely take a look, because yeah, these are exciting conversations.
Yeah. No, it's cool, and because Miguel, I think his spin-off startup that's one of his points in the proposal, so he has some sort of commitment, and as I got, Dom as well has the okay from his boss, so we have a few people who do push, so that's really cool.
Fun. Cool. Yeah, so I guess maybe a couple updates from me is last week I had a chat with the Coils folks, so Matt Rockland and Hugo. And so got the Buchvernong inversion up and running with Dask on Cheyenne, which was really cool, is that I was able to run all 1,000 soundings in parallel, and it was done in like 2 or 3 minutes, which was just really satisfying. And that was using sort of the SIL mesh on SimPEG. So we had written that example before EM1D existed, but it's kind of encouraging to see that, is that it is then easy to sort of set up a simple inversion with SimPEG and get that up and running. There's some subtleties with how you set up the cluster, so that you don't get the threads running over each other. There were a few different layers of things to sort out there. So I did actually talk a bit about that in the chat with them. I think it's all on YouTube if you are interested in watching. I'm going to try and clean up that notebook so that it actually is a little more usable on other machines as well. Like right now, it's tied exactly to Cheyenne, but I'll try and get an example running where you can run it locally, and then maybe on NERSC as well, which is the LBL computer. So yeah, we'll hopefully get a few examples out of that.
It's wonderful. That will come around there again for sure. If you could archive this, that would be super useful.
For sure. Sagi, did you have a...
How many cores did you use, Lindsay?
So I requested 10 cores with 10 processes, or sorry, 10 nodes with 10 processes on it each, so 1,000.
Oh, so it was actually using 1,000 cores, 1,000 CPUs. Oh.
Yeah. So it's really satisfying to see when the Dask graph starts going and you just see all this work getting done.
I still want to get there with the DC. Just, oh, it's almost getting there.
Yeah, well, this one is easier because it just is totally separable. Yeah. Yeah, and then I guess, so the other thing is I'm starting to do a bit of work with Teddy, who's at U of C, working with Adam Pedlasecki. She's interested in mostly DC examples for monitoring. And she's got kind of a cool problem. It's looking at monitoring beneath permafrost. And so you have this surface layer that you're pretty sensitive to that changes depending on the season. So if it's in the summer, it's going to be more melted. And if it's in the winter, it's going to be much more resistive because it's all frozen. And then trying to monitor a contaminant beneath that. And so we're going to play around with combining some of the work Dom did with the SUM map to basically set up a like parametric plus smooth inversion components. So invert for a parametric description of the background, and then have the contaminant be a smooth piece. So we'll keep you posted. I'm going to try and get a minimal example up and running with her in the next couple of days. So should be a fun example to play around with. Kind of, yeah, showing off the mappings, and so it'll be cool. Yeah, and then I think that's the other thing, and this is a longer conversation than 2 minutes, but the other thing that I've started to be thinking about again is thinking about what we want to sort of have written down in terms of governance of SimPEG, as just like, you know, right now I think a lot of our decision-making process happens at the meetings, which is great, but I think we want to sort of maybe at least document that somewhere. So I'll try and get a few thoughts down, but then, and we can chat about it, and I'll share some links and stuff around. But if there's other things that you think we should have sort of somewhat formalized with SimPEG, I mean, I don't think we need to be like implementing new processes at this point in time of like, yeah, I mean, I think overall things are operating well, but it's if there's things that you see that we could be doing better just in terms of how we manage community and manage changes and things like that, or if there's stuff that you think we should be formalizing in terms of people's roles and things like that, I could see that being useful, as having a bit of role definition and things like that, both for ourselves, but also I think, well, for ourselves sort of within the community, but I also think for folks to be able to advertise and speak about what you do and what you contribute to SimPEG, it would be nice if we have a bit of language around that and kind of definition as to what that means. Yeah, so give some things some thought. If you have ideas, feel free to just send things around, but I'll try and get a bit of a document or some issues and stuff like that sketched out, so we can have a bit of a more structured conversation around that in the coming weeks. All right. Well, I guess we're on the hour, or half hour. Does anyone else have other burning items, things you'd like to bring up before we wrap up?
Is anyone interested in doing another coding hacking thing at some point soon? It's been a while.
Yeah.
Not sure when yet. Like, I think our next one is due to be a Wednesday afterwards one. But we can also do another Friday one if people are interested as well. Anyone have any preference? You know, Dieter can only do the Wednesday ones.
Wednesday afterwards, so it'll be fine. Friday night is a bit late to me. But yeah, I thought, and it probably also goes into Lindsay's thing. I don't know what would be the approach in Discretize and SimPEG. There are like pull requests from people, sometimes even outstanding, that no one has replied, and I don't know myself, should I not? What is the government? Should we do it? Do we leave it to see what happens? So these, yeah, that's what Joe says. If you sit together, that we could go through those as well. So next Wednesday would be fine for me, but it's the middle of your day, so I don't know if that's good for you guys.
We can do next Wednesday, as long as we plan ahead, right?
That sounds good.
I'm cool with that.
Excellent. Perfect. Okay. Well, thanks everyone. We'll be in touch on Slack and see you all next week.
Thanks. Have a good one.
Good day.
Yeah.